Today we are going to learn about fuel combustion. And when we talk about fuel, a fuel is any material that can be burned to release thermal energy. And when we also talk about the combustion, a combustion is the place where the burning takes place. Now, we have a question. We have to deal with this question.
1 kilomole of octane C2H6 is burned with unknown amount of air during a combustion process. An analysis of the combustion products revealed that the combustion is complete and there are 3 kilomole of free oxygen too in the products. The combustion products contain CO2, H2O, O2 and N2 only. The molar mass of CH2 and air are 12 kg kilomole, 2 kg kilomole and 29 kg kilomole respectively. Determine the air-fuel ratio and the percentage of the theoretical air used during this process.
Now we have to write a chemical equation for the air-fuel ratio, the reactant and the product side before we calculate the air-fuel ratio of the combustion process.
Now this is the fuel. This is the fuel plus three this is the fuel, this is the air. So now this is the product, this is the reactant side, this is the product side. Now we have to balance the equation. If you look here, here is not equal to here. We have 2 carbons here, but we have only 1 carbon here. We have 6 hydrogen here, we have only 2 hydrogen here. So we have to balance the chemical equation. So now, to balance the chemical equation, we have to represent the value with a variable, any variable, NFO2 plus 3.76 N2. Let's make this place X2 plus Y820 plus 3O2 plus N2 Z. Let's make this place Z. So now we have to balance the equation. So C equal to X equal to what? There is 1 carbon here, there's 2 carbon here. So S1 equal to these 2. Now we have balanced the carbon. So now we are going to hydrogen. So hydrogen is represented by Y. So now we have 2 hydrogen at the product side and 6 hydrogen at the reactant side. So 2Y equal to how many hydrogens here? 6. We divide both sides by 2. 2, 2. So Y equal to 3. That is the hydrogen. So now we are going to look for oxygen. You have to look for oxygen. Now when we look at the product side, we have 2 oxygen here So we will make 2x plus, we have only one oxygen here, so plus y plus how many oxygen is 6 oxygen here, so 6 plus let's make this place 6z, no, 6k. So now the oxygen is hot. At the reactant side, we have 2 oxygen at the reactant side, so it's NF equal to, we have 2 oxygen here, so it's 2x plus 1 oxygen here, so it's y plus 3 times 2 oxygen here. So now we get 2 NF equal to 2. How many x we have here is 2 plus the y is 3 plus 6. So NF equal to 2 times 2 plus 3 plus 6 equal to 13 divided by 2. So the NF equal to, divided by 2, equal to 6.5. That's the oxygen. Now we have to look for the Z. So the Z, we know that the oxygen is this, so the Z, the N2 equal to this oxygen here, 6.5 times 3.76, so equal to times 3.76 equal to 24.44. Now we have finished balancing the equation. So now we are going to write all the numbers that we have calculated for. So C2H6 plus the oxygen is 6.5 into bracket oxygen 2 plus 3.76 and 2 bracket close. The product side, the X is hot 2 oxygen 2 plus the Y is 3 H2O plus 3 O2 plus 24, the Z 24.44 nitrogen 2. So this is the reactant side. This is the product. So now they ask us to calculate the air fuel ratio, and now the formula for air fuel ratio of the combustion equation is air fuel ratio equal to mass of air over mass of fuel equal to molar number of air times mass of air all over molar number of fuel times mass of fuel. Now in the question they give us the molar mass of carbon, they give us molar mass of hydrogen, and they give us molar mass of air. So now the molar number of air is what? 29. So 29 times the molar mass number in the equation here. 21 divided by 21 equal to 1 plus 3.76. That is the nitrogen. So equal to 4.76 times what? 6.5. They are dealing with the air all over the carbon. The constant, the molar mass of the carbon is what? 12 is given in the question. The molar mass of the carbon is 12 times the molar number, the carbon is 2 here, so it's 2 plus the hydrogen, and the constant of the hydrogen here, hydrogen is 2. This is the constant of the hydrogen is 2, so 2 times the molar mass of hydrogen is 2, and the hydrogen here is 3, so 3. So now equal to 29 times 4.76 times 6.5 all over 12 times 2 plus 2 times 3 equal to 29.908 kilogram of air over kilogram of fuel. Okay, now the question continues. He said you should calculate for the percentage of the theoretical air used during this process. So now we have to find the theoretical air using during this process. So now we are going to balance the chemical equation again. The fuel they give to us in the question here, is what? C2H6 plus oxygen is 2 plus 3.762 equal to the CO2 plus H2O plus hydrogen 2. So now this is the complete combustion they give to us. So the actual combustion process So now we have to balance this chemical equation. Now C2H6 plus NFO2 plus 3.76 N2 bracket close. The product side, we make any variable here. So X CO2 plus Y H2O plus Z N2. So now we know C, the carbon at the product side is 1 and the carbon at the reactant side is 2. So X equal to 2. Now H at the product side, H equal to 2. So 2Y equal to, the H here is what, 6 at the reactant side, 6 divided by 2. So Y equal to 3. Now for the oxygen at the reactant side, we have 2 oxygen equal to 2x plus y, 2n equal to 2 plus equal to 2 times 2 plus 3 equal to 7. Divide both sides by 2 equal to 3.5. Okay, now we have to write inside the chemical equation balance. So C2H6 plus the nitrogen is what? The oxygen is 3.5 into bracket O2 plus 3.76 N2 bracket close. The product side, the X is what? 2. CO2 plus Y is equal to what? 3 H2O, and the Z here equal to what? Z equal to the oxygen at the reactant side, the oxygen times 3.76. So the oxygen is what? 3.5 times what? 3.76 equal to 3.76 equal to 13.6 nitrogen 2. So at the product side, the nitrogen is 13.16 N2. So now we have finished balancing the chemical equation. Now we have to find the air-fuel ratio of the theoretical air used during the process. So now the air-fuel ratio equal to mass of air over mass of fuel equal to molar number of air times mass of air all over molar number of fuel times mass of fuel. Now we know our molar number is 29 times oxygen. 21 divided by 21 equal to 1 plus 3.76 equal to 4.76 times 3.5 all over the carbon. The molar number of the carbon is 12 times what is the carbon here? The molar mass is 2 all over 2 plus the hydrogen. The hydrogen here is 2, and the hydrogen here, the molar mass of the hydrogen is 2, so 2 times 3. Now we put it in the calculator and see what we're going to have. 9 times 4.76 times 3.5 all over 2 times plus 2 times 3 equal to 16.105 kilogram of air over kilogram of fuel. Now you have to calculate for the percentage of the theoretical air used during this process, the percentage of the theoretical air. So now the percentage of the theoretical air, equal to air fuel ratio of excess air over air fuel ratio of complete combustion times 100%. Now so now this is the excess air. This is the air fuel ratio of the excess air. Now this is the complete air fuel ratio. So equal to the excess air. Equal to 29.908 all over 16.105 times 100 to 9.908 16.105 times 100. Therefore, the theoretical air equal to 185.706%.